In this second tutorial, we're going to talk about an image and depth capture device known as Kinect. Kinect was a product launched by Microsoft in the 2000s. This was the first, this was the second. Both were released for the Xbox console, but due to its lack of success within this system, it was discontinued. The thing is, it was widely used by programmers, DJs, creative programmers, and artists who made interactive projects due to its low price and relatively good quality. They are very easy to find. We can find them on any second-hand website, and to be able to use them with our computer the only thing we need is the device, which we opted for the Kinect V2 since the Kinect V1 has much less quality, and the Kinect Azure, which has been the latest version, is also discontinued and is a little more complicated to get. So once we have the Kinect V2, what we need is an adapter that allows us to connect it to our PC. They are around €20, you can find it anywhere, and finally we need the SDK that will allow us, let's say they are like the drivers, what allows the camera to connect to our computer, which is as simple as downloading it here, installing it, and then we can jump to TouchDesigner where we already have a series of components. The great thing about working with Kinect and TouchDesigner is that there are many pre-built features that allow us to work with Kinect very quickly and easily. If we press the Tab key, we'll see a component called Kinect that immediately returns a depth image. What does a depth image mean? It means that the image interprets the closest thing to it as 0, 0 is black, and 1 is the furthest it could be viewed, which would be white. If we look here at the parameters that this operator allows us, we will see that we have different types of images. We have the color image, which is an image from the RGB camera. We have the depth image. It is important to note that the depth sensor does not have the same dimensions as the RGB sensor. For this, we have a small toggle here called Camera Remap, which would transform this ratio so that it matches the ratio of the RGB camera. We have an infrared camera, which captures an image through infrared sensors, which means that the image does not vary depending on the lighting conditions, which can be useful at certain times. Player index, which let's say what it does is render the silhouette of the person in front of us. If there are two people, they would be rendered in different shades of gray. In this case, where I am, you can see my silhouette here. It can be used to remove background information or to show that 2, 3, or 4 people are in the image. Finally, we have the color point cloud, which shows us this image in these colors. What it does is map the RGB colors to XYZ position vectors in three-dimensional space. As I told you, TouchDesigner already comes with a lot of pre-created components that we can use to visualize this. For example, if we go to Point Cloud, we will see that we have a component here called Point Render that if we put ourselves on top, we can see that it has two inputs, one called Positions and one called Colors. So for example, if we connect this one that I already told you that what it is doing is mapping RGB to XYZ in three-dimensional space, we will see that we can see ourselves in 3 dimensions. We turn, okay, here I am in 3 dimensions. If I turn like this, I can see how I stretch my arms back and forth. And if we add the color and remove the camera remap, because obviously the RGB camera is already in the proportion that we want, we can see how this point cloud is already displayed with the colors of reality. This can be used for different effects or different things. And another very useful thing about a depth sensor is that we are aware of where things are in space. This means that we can remove elements that do not interest us. For example, if we wanted to have just me in the image, which is this person who is moving their hands, we could get the depth image, which is called depth unknown value. It means all these black points that are actually points of which we have no depth information, we turn them into one, that is to say white. We can pass it to a component called threshold that what it does is compare the values of the image with a number that we can set here, and based on that comparison it renders it well or white or black. In this case, what we are going to do is click on Grader, and based on the luminance we can see how we can now start to cut things out. For example, here it is only me. In fact, we could even continue and leave only my hand once we have this, which is what is known as a clipping mask. we can basically use a component called matter that has three inputs, one that is going to be the image that is placed on top, one that is used as a background, and one that is the clipping mask, which is this. We connect this to the input matter. We say that we don't want it to look at the alpha but rather to look at the luminance, because in the end everything that is white we want to render it as an image, and everything that is black we want to render it as transparent. The background, as I said, is going to be a transparent image for which we use this component called constant, which what it does is render an image in the color that we want. In this case it will be with the alpha 0 so that it is transparent, and again we paint here the color version without the remapping of the camera that would go to the first one. And now we have this clipping here that, as I told you, we can keep only the hand. We can play with this slider to see how much depth we want until we have everything. As you can see, there are many points. These artifacts are normal. In the end we get the depth by throwing rays that when they touch a surface, the camera knows how far away they are, but we can fix them again with one of the elements that we have here inside the palette called dilate. Dilate has two functions. You can either dilate or erode. In this case what we want is to erode all those little points so that they are erased and have a slightly cleaner image. We can play with these sliders again so that we get the image that best suits what we want, and this new one can be used again as a matte and we have a much cleaner image. This can also be applied to the point cloud, so that if we link this again to a point render component, we will only be rendering the part that interests us and not everything that is inside the room. Goodbye, thank you very much.